So let's imagine that we have a system with an object on a table of mass m, and it's connected by a string via a frictionless pulley to another object that's hanging of the same mass. It looks like that, and we want to find, we want to solve for the motion of the system. Obviously, there will be acceleration this way, and they're connected, so we can figure out the speed of this object moving to the right and the speed of this object as a function of time downwards. It'll be the same as that, speed to the right, because they're connected, and so we can figure out the position as a function of time. We can figure out all of those things. So if we do this via ma equals f, it's really a one-dimensional system. Again, we could do a free body diagram. We have the force of the tension. So this is another thing to notice. If we use this approach, we need the constraint forces. The tension force appears here, and so we have m times, let's say that we have a coordinate, let's label it in green, where the distance from here to this object we call x, that's going to increase. So we can say m times x double dot is equal to the tension force. Tension force is to the right, it comes in positive, that's our convention. And we do this for the other object, and we have m. Now we need a coordinate for that. So let's say that let's make the distance from here to here is, that's a fixed quantity, we can call it s. And let's make the distance from here to here, we can call that y. And I guess we'll introduce another coordinate when we do Lagrangian formalism. But we have m y double dot, but, right, so we can write m, the acceleration here, m y double dot is equal to, there's a tension upwards here, which is given that the tension is positive on this one, then on this one it would have to be negative. So we have minus tension here, and we have the gravitational force on this one, which would be mg. Would look like that. But if the length of the string from here to here is L, then we have that S, we subtract the X, right, that's this part, and plus that must equal to the total length of the string, and that's a fixed quantity. So we can say that, well, S plus Y is equal to X plus L, and so when we take derivatives with respect to time, we get Y dot equals to X dot, and of course Y double dot equals X double dot, so they're the same, so we can do just in terms of X, and that's mg minus t, or maybe we can write these both in terms of Y, but there's only one acceleration here. So we have this coupled system, and so we add, we get 2m x double dot is equal to just mg, and so we have x double dot is equal to g over 2, And of course, if we integrate that, so if we're using x, we're sort of thinking of the acceleration of this object. That gives us x dot is equal to g over 2, where we integrate that t plus some initial speed, if the system was given some initial speed, plus v naught, and therefore the x position here is gt squared over 4 plus v naught t plus, I guess whatever we call its initial position along here, whatever it is, whatever that is, we're calling, well, here, it's actually there, we're calling that x naught. Okay, so we solve for the motion completely. Let's look at the Lagrangian formalism. So if we decide that we want to use the reference point being here, then we have another coordinate here. We have some z here. And maybe we can say that, of course, this is some fixed height. And so we would say that z plus y, right, z plus y is equal to that fixed value. And so z is equal to h minus y. And so the potential energy would be mg z, which is, in terms of y, would be mg h minus y. And so we can write the Lagrangian. It's kinetic minus the potential, and the kinetic is just m over 2 times the speed squared, but it's twice. Right, so we have m over 2 times x dot squared, but if we're using y, x dot and y dot are the same thing, so we have y dot squared plus y dot squared. We have minus u, which is minus mg h minus y, and so we can write that as m y dot squared plus mg y, right, minus mg h, which won't affect anything. And so we need d by dt of dl by dy dot, and that is, dl by dy dot is just 2m y dot, and so we have 2m, and we take another derivative, we have y double dot, and then we do dl by dy, which is equal to mg, and therefore this is equal to that, and so we have 2my double dot, or x double dot for that matter, is equal to mg, and so we have y double dot is equal to g over 2, but that's also equal to x double dot, and so we end up at the same place for, in this case, if we want to think of the top object, where its position is in the horizontal direction, the x coordinate.